Hi everyone. Today we have Sean Alvarez and Ajay Chankramath for Deep Engineering. They are currently co-authoring a book titled Platform Engineer's Handbook with Pack Publishing, a practical guide to building scalable, secure, and AI-augmented engineering platforms. Sean is CTO for Brillio's life sciences business, where he leads engineering teams and advises clients on platform modernization and enterprise cloud strategy. With 15 plus years of experience, Sean has held leadership roles at companies including ThoughtWorks and Brillio, while presenting at industry events including Platmosphere and QCon. Ajay, on the other hand, is a technology leader and the founder and CTO of Platformetrics. He previously served as Brillio CTO for platform and product engineering and held senior roles at ThoughtWorks, Oracle, and Broadridge. Ajay is also a platform engineering ambassador and a frequent speaker at global tech conferences. In today's episode, we'll be diving deep into one of the most important and often misunderstood topics in this space: SRE versus platform engineering. Two essential but often conflated roles. We'll explore how they differ, where they overlap, and why their collaboration is critical in today's engineering organizations. Sean and Ajay, a very warm welcome.
Thank you. Wonderful to be here.
Sean, I'd like to start with you. Can you take us back to the moment when you first realized you were doing what we now call platform engineering? I imagine the term might not have existed yet, but the work was already there. We would love to know about your journey.
Yeah, it's a great question, and thank you. I've always worked in somewhat regulated industries, life sciences, the financial industry. And in those industries, the release process tends to be, we'll call it cumbersome. There's a lot of compliance issues, there's a lot of sign-offs that need to happen, and a lot of double and triple checking that things aren't going to go wrong or that auditing is going to get messed up. And when I first started working with companies that would burn, deliverables onto CDs and move things back and forth and tried to introduce automation, there wasn't a whole lot of trust in automation at first. So that resulted in these centralized teams that would, be up all hours of the night doing deployments over and over again. And there really wasn't a trust to move to something like you'd call DevOps. However, there was this desire to speed up the development process as the industry matured, as more startups started to come into these industries that were being a little bit more nimble. So we wanted to turn those deployment processes and that SDLC less of a gate and something that teams would dread. I need to submit this now to the DevOps team or the operations team, and more into an enabler for teams, something that actually made their jobs easier. And as we started to do that, we started having to really work across silos to make sure that we could put automation in place that included concerns from security teams, networking teams, even compliance teams, and upper management with governance. And that's really where I think platform engineering started to take off for me, was this idea that we can do automation while ensuring that our deployments are still safe, compliant, not going to produce downtime, and really take into the interests of all of the different silos throughout the organization and allow the developers to actually move faster, while keeping the organization kind of, trusting that things were going to go well when it released.
Oh, that's a really interesting and inspiring story, Sean. I know that every company tends to have its own unique engineering culture. In your journey, also, you have come across various organizations, and how have those different environments shape your personal understanding of what platform engineering really is?
Yeah, so as I moved, into more of a consulting role where I was working across industries and started to see more and more organizations that maybe were closer to being startups and willing to just move fast at the risk of breaking things and seeing the industry mature. I really started to see that it wasn't just allowing developers to move fast, but there was also this consideration that we needed developers to want to use platform engineering. Because as you have these individual development teams that are full stack and maybe in control of what they're deploying and how they're deploying it, you can get this view that platform engineering is something now that we need to migrate to. We have to put extra work on our backlog. It's one more check that we have to do. And we need to be able to provide them something that they want to use, not a build it and they will attitude, but something that's more product oriented that, no different than if you make a product for external customers and you have to get it into the market and gain market share and thinking about, bringing in more and more customers to your platform. If we think about engineers as internal customers to this and that adoption rate, that's really where it can be successful because now we're marrying the interests of the organization and the leadership with the interests of the developers. And it can really become a powerful practice in that case. Ajay, I know you've seen a lot of that with product oriented practices as well. Did you have any thoughts on it?
Yeah, absolutely. Absolutely. So, yeah, thank you for that perspective, Sean. And nice to see you, Srishti and Sushma, and all the audience. So, if you look at my journey, that's been slightly different, but not that dissimilar to what Sean has seen, right? So let me actually take you down that memory lane a little bit. So many moons ago, right? I mean, so I had a role where I was supporting the developers. So I was a developer myself. My primary job, my first job was essentially building some complex algorithmic software. But one thing I started seeing was that developers always had some level of friction. I mean, they couldn't get things done the way they wanted to do it, my own team. So the thing that was very, very different between now and what we had then was the fact that, we always had this idea of a different construct, a different set of people supporting. I think Sean briefly alluded to that, right? So what I ended up doing at that point was that I looked at the two of the fundamental principles of software architecture, software design, right? Things like this loose coupling and high cohesion, which all of us have been looking at for the past, I don't know, 50 years or something. So as we were really trying to do that, first thing I did was I started looking at what are the areas of challenges the developers have. And then we were able to really come up with an idea of saying that, hey, if we were to create some reusable components, that immediately improves the productivity of not just the developers. Remember, those days, the constructs were slightly different, right? We had this true construct of developers writing code and then throwing it over the wall to a bunch of people sitting around and, this gray haired people sitting around and building all this complex software. And that actually becomes the product. So, and this was about 25 years back. I have a patent from those days and people still call me on this one. So this was called ROMs, and we conveniently named it ROMs, this particular patent. It is called reusable object modules. And those days, remember that these were the days prior to DevOps and SRE and platform engineering and all that. And now when I look at that, that was essentially the fundamental building block of a platform, right? You're building a capability, a reusable capability as a library. And then we went ahead and presented at lots of conferences and all those things. So that was really my first foray into looking at something like this, right? And the idea is that this spark for something like this sort of comes from the fact that you're applying software principles, and that's probably going to be the theme of our conversation today across the board. Like how do you actually make sure that we apply software principles to everything that we are talking about? Primarily, the topics today is SRE and platform engineering, right? So make the long story short. So what happened at the end of that was that, my leadership looked at me and said that, hey, you build this one, so now you must know everything about it. Why don't you actually go set up a team and run with it and, do whatever you want to do? So that was that transition from a, actual software developer building product software to doing more of that support related activities, right? We used to call those teams those days as software productivity automation, all that, because we never had any of the other terms, right? So I think, yeah, so I think that's been that first foray into it. Um, One of the other things that I think Sean briefly mentioned was that, how did like different engineering cultures sort of come together in this space, right? So I've mostly worked for large companies and probably some mid-sized companies, right, before getting into consulting very late in my career. So in the large companies, one of the things that goes in is that federated model, right, which is actually a good model if you think about it. So federated model is very simple to understand. So you have, think of it like, organization having a centralized set of services and a bunch of, services that are built on top of it by the individual teams around it, right? So that model is really phenomenal because smaller teams then have the autonomy to be able to go in and make the kind of changes that they need to make themselves. They might actually do it by having dedicated resources within their teams, or they might actually say, "Hey, this is what we want." But the problem then is that, think of it like a large company with, a federated model. The centralized team will have a huge backlog of things to do. So that almost never works out. So it really gets back into that self-sufficiency where the individual teams are able to do some of those things. So, on the other end, what has happened is that with the advent of public cloud over the past 10, 15 years, or maybe 10 years, we are seeing a lot of these services coming out of the CSPs themselves, and which has made it far more easier for smaller players to sort of adopt these things and, really make sure that it sort of works within their ecosystem.
Thank you for the wonderful insight, Jay. That was very interesting. And Sean, I would like to ask you what the common misconceptions are in this area when teams today are practicing SRE and platform engineering. What are some of the biggest misconceptions you see?
Absolutely. Let me start there, and I'll let you jump in, Sean. So I guess one of the biggest misconceptions is that all these constructs that we are talking about, whether it's SRE or platform engineering or DevOps or DevX, these things are all like newer terms or newer fads that replaces each other. Absolutely not. One of the things that we will be covering in our book, and which is something that is sort of getting better understood within the industry, is that all these roles or the terms have got a play, so essentially they all are relevant in the larger scheme of things. So the way we look at it is very simple, right? Because we want to start off by that definition so that the rest of the conversation becomes far more easier. So the way we see it is that DevOps is not a team, or should not be a team. It is a team today in a lot of companies. It should not be a team. It should not be somebody's title, but instead it should be more of a cultural paradigm that improves the collaboration communication between all aspects of SDLC, right? So think of it that culture paradigm thing. If you look at it that way, then what is SRE? So SRE becomes that applying the software engineering principles to operations for creating highly reliable production systems. And now the newer term that all of us keep talking about is this DevX, or developer experience. So that's been there from the beginning of time, but it's that experience of developers interacting with the tools, frameworks, processes, everything through SDLC. So if we clearly define these three constructs, you might find that there is a common element across all of these things. How do you actually provide the right kind of capabilities to ensure that the SRE and the DevOps culture and the DevX and can all work together? That's where platform engineering comes in. So one of the things that Sean and I have been doing, for the past couple of years, is we've been writing a lot more about it. The way we sort of articulate it is that platform engineering is in the center, in the middle of everything, all this, the other three constructs, where it provides the capabilities for the developers to be more self-sufficient, SREs to be more self-sufficient, and DevOps culture to actually percolate throughout the organization. So if you look at it that way, that sort of takes away that misconception that platform engineering is coming, and SRE has been around since 2004, I believe, and now after 10, 15 years or 20 years, now it's been completely replaced. Absolutely not. It serves a completely different purpose. Feel free to jump in, Sean, with your perspective on this.
Yeah, absolutely. I've seen in a lot of organizations where, SRE is seen, solely as production support. So does that mean platform engineering is just going to automate that away from them and replace them, or are they maybe just automating it themselves? And I think there is a large role for SRE in making sure that production is reliable, not necessarily production support. And platform engineering, to Ajay's point, is really across the whole SDLC. everything from a team starting up and maybe creating a new project or even onboarding their own team members, all the way through to building and deploying the software to production, having the runtime that the software is on, allowing teams to very quickly innovate, and then also, again, making sure that things are scalable, that they're secure, that they're compliant when they're running in production. And SRE definitely has a role in that. SRE needs to inform what platform engineering does according to what they need to make their jobs more efficient. But they're not the only user of the platform, and they're certainly not the only creator of the platform by any means. They have to work with development and product and business owners in order to make it truly successful.
Okay, so SRE is not just a rebranded platform engineering is not just rebranded SRE. It really represents a genuine shift in mindset and practice. Also, there's a lot of overlap between SRE, DevOps, DevX, and platform engineering. I know you've touched upon this topic a little bit, but would you like to explore in detail what each of these bring to the table and how you personally draw boundaries between them and where they are different and similar?
Absolutely. Great question, Sushma, right? So to start with, let me take a step back and just provide maybe a one-line definition for people to sort of understand that, right? So I briefly mentioned earlier that DevOps is all about that cultural movement that's all about breaking down the silos. So Sean mentioned applying platform engineering or trying to improve the SDLC across the board. So if you think about your path to production, from the moment you're conceptualizing an idea to getting things in production and running it in production, there are lots of handoffs, lots of steps there, right? I mean, ideally, we at least have like 6 or 7 high-level steps, right? We talk about plan, design, code, test, deploy, and operate, right? So and they can, integrate a lot more steps into it, especially if you start thinking about DevSecOps as a separate activity that is coming in. These days, we do see that a lot of those security aspects are all built into the platform capability so that it's not as called out as separate activity, but for the purpose of discussion, let's talk about it that way. So if you look at it that way, so this whole idea of DevOps is that culture that ensures that the silos that is naturally going to happen within each of these steps are going to be broken down. Now, SRE started off, as we all know, as Google's implementation of, how do you actually apply software engineering principles to operations? Because historically, the operators were people who would have not the software development skills, but these are people who know how things run in production, how the machines work, the systems engineering, and all that kind of things. But Google sort of threw that whole idea out of the window. They said that an SRE should be people who should not only know the system side of things, but also the people who can really go in and make changes to the code. Is that happening like that today across the board? Absolutely not, right? I mean, there are pockets in which that's happening, but one thing that Sean and I keep saying all the time is that Google's SRE works for Google and everybody else's SRE works for them, right? But at the same time, the idea being that an SRE should be somewhat of an elevated role, who are far more than a system administrator. So that is that fundamental idea there. But together with that, sort of laced within that is the idea that if you're an SRE, you should understand software design and software development far better. So that also invariably leads to this idea of now if I know software, if I'm going to do the software work, I should have some of those capabilities to do that software work. So that is where the definition of SRE is. So DevX is essentially that outcome or the measurement of being able to being more productive as a developer. So I think that is something that is now well understood, well measured. There are some awesome companies and researchers and all who have been working on some of these spaces. I know a lot of our audience listeners would have actually read Accelerate book. That is one of the tip of the iceberg. A lot of work that is being done by Jane Kim and IT Revolution, and as well as a lot of different researchers. And at GetDX, Abby and team at GetDX is doing a lot of work. So there's a lot of work with respect to measuring what you are trying to improve before you improve it. Because we all know that if we need to improve something, we first need to know where that is, right? So that part is being done phenomenally well today with a lot of research going into that. With all these three sort of defined, the platform engineering for us is the idea that is that the tools, process, techniques. So it's not just a tool, right? This is not just process, but tools, process, and techniques that can actually improve all these things that we are talking about. And that is why platform engineering is sort of important. So platform engineering is not about a team of people trying to make sure that your protection systems are working well, or even your development systems are working well. That is not what their role is. So it's never a situation where an engineer or a developer working on something says that, hey, I've written some protection, a code that should go into protection from a product point of view. Now a platform engineer come by, take that and do your magic with it. Nope. That is a complete anti-pattern. It has to be always like, what do I as a developer need to be able to be more productive, to reduce in a manner in which I'm self-sufficient to be able to do something, so that I can actually get this through that SDLC process as efficient as possible, as fast as possible. And that's where these capabilities coming in. Another simple way of looking at it, I do tend to use this example all the time, is that most of the software developers have been using APIs and capabilities for the longest time. Yeah, think of this like a bunch of libraries or APIs that you have that's available for you in a way that you want it. So, and Sean briefly mentioned this. This is not about we'll build some platforms and somebody will come and use it. Nobody comes and use it, right? So, but going at it the other way around, from a developer's point of view, me as a developer, this is what I need to be able to get my work done. And where is that need going to be fulfilled? And that's where the platform engineering sort of comes in.
Yeah, and I think one thing that we'll get into here is what I think is unique about the platform engineering handbook that we're writing is we're taking a very practical view of things. We're really getting into how do you create these things and less about why do you create them in the theory. So if I take a step down from this, and again, it's not just about tooling, it's not just about techniques and processes, it's a combination of all of them. But I think if you think about the type of tooling these different roles use, it starts to bring out why these are separate responsibilities to some degree. And it's a bit simplistic. But if you think about platform engineering, a lot of people are immediately going to think of, well, Kubernetes, right? Platform engineering runs a Kubernetes cluster. That's certainly not all they do. They're automating the deployments into the Kubernetes cluster in some cases. It may not even use a Kubernetes cluster. They're automating the ability for developers to quickly spin up new projects, to quickly spin up new deployment pipelines. If you think about SRE, one of the big things SRE is responsible for are those SLIs, SLOs, SLAs, which are all metrics driven in terms of what's running in production, how well is it running, and a big part of that is observability. So you may have an observability platform. Now you don't want your observability platform running in the same Kubernetes cluster, for instance, that's running your applications, because if it goes down, you're not going to know about it in time. So those are two separate responsibilities in some ways that both teams are interacting with, but one is going to be a bit more accountable than the other. Developer experience, I think most people immediately jump to Backstage, developer portals. That's what we mean by developer experience. Now, it's certainly not that. There is a lot of metrics and a lot of developer software engineering intelligence that has to go in terms of measuring that. But if you do look at it as something like Backstage, what that's doing is it's actually making it easier to use what platform engineering has provided. It's giving you that interface that you can go into to take advantage of the capabilities. It's giving you APIs and programmatic access to spin things up. Maybe you have a CLI interface to it as well. But again, it's running kind of on top of the platform to provide you that interface layer that developers can very easily now take advantage of it and work through their workflow in a much more efficient and easy way, ultimately making it something they want to use because it makes their job better.
Okay. Thank you, Ajay and Sean. Those were really great insights. And I'm sure that this would help clear the air and, and the overlap between in the common misconceptions between SRE and platform engineering. So yeah, those insights would be really helpful for our audience. So now I would like to understand, you know, on the pain points of platform engineering. So you guys have spent years in building and scaling platforms across various organizations, and I'm sure that journey would have come with its fair share of tough lessons. So looking back, what would you say was one of the hardest lessons you learned while building or scaling a platform at an enterprise level?
Yeah, I can take that. So when we think of enterprise, right, versus, startups or even a little bit, medium-sized growth stage organizations, enterprise to most people is immediately going to mean process, right? It's going to mean multiple levels of management. It's going to mean, multiple different processes that you have to follow. And what that drives to is a desire for standardization. In fact, in a lot of cases, you see platform engineering being put in as an idea of a way to get away from the sprawling culture that DevOps introduced in many organizations where, you build it, you run it type mentalities where everybody's doing their own thing and try to find a way that everybody can, be using the same pipeline that has the same observability so that we can sign off on it in the same way. And trying to make a platform engineering effort fit to the entire organization, quite honestly, is a recipe for failure. It's going to make things much more difficult, much more complicated. It's going to lead to extended timelines because you always have those teams that are doing something a little bit different. And now you're trying to accommodate all the edge cases. And then you have teams that start to feel stifled in their ability to innovate because now they're restricted by what platform engineering has provided them. So they start to try to find ways to work around that so that they can do what they need to do on a day-to-day basis. And it really just kind of leads to everybody finding friction with the platform. But if you really aim for that 80% is usually the number that I think of. We want to serve the 80% of the organization that is doing things in a way that can be standardized to some degree. And then those other 20% of teams that don't fit that, maybe there is opportunity for them to change their own process to fit into it versus forcing the platform to fit into what they're already doing. And that will lead to a lot kind of smoother way to develop this. It'll lead to a lower time to value because now you can get something out quickly and you can start to see the majority of teams using what's being produced and getting the benefits of it.
So you make a really great point, Sean, with respect to that 80-20 rule, right? I mean, just like everything else, you're never really going to have that 100% success, and you should never really go for it, right? Because that's not where your ROI is. But how do you go about doing it, right? I mean, so one of the things that we will be touching upon in the book, not from a principles point of view, but the practical hands-on experiences, the 7 principles that you really have to adopt to ensure that you get to that 80-20 or 80% success, right? So let me sort of talk about the anti-pattern and pattern without going into too much details around it. The first one is like, and I briefly measured this earlier, right? Measure what you're really going to improve. So if you're going to have waste and friction, measure that so that when you do something, you can clearly say that, hey, I made this improvement. So we made this improvement for the organization. So super important. Number 2, to me, that is probably the most important thing that differentiates platform engineering from all the other constructs that we are talking about, even including SRE. That is that strengthening that technical product management perspective. So this is not about building some automation. This is not about building some software, but this is about building that as a product. Just like you have external products, your platform engineering activities, the capabilities that you build are also products. So I think strengthening that is a big challenge that most of the organizations have. Even organizations that have adopted platform engineering don't do that, right? So that is that second principle. The third one, this is a huge challenge in maybe in it's not just the large organizations, all kinds of organizations, is that when you put a bunch of engineers into solving problems, they all like to go build stuff, right? And now the question is that what do you need to build? You sure have to build things, but what do you have to build? These days, the number of products and the capabilities and everything coming out it's mind-boggling, right? If you look at all of that, that's all you have time for. So I obviously don't want to get distracted too much with it. But do your research, do your studies in such a way that you balance that buy versus build activities. Do not build anything that you can buy with a more cost-effective way, because this is so hard for engineers to accept, right? Because when I look at a product, I'm sure a lot of our listeners, when they look at a product, say, I can do that better than you do, right? And that's not the point. Where is the TCO, right? And that is the third principle that you think about. Fourth one, this is again a huge part of how platforms really work. Make sure that when you're building an engineering platform, so Sean briefly talked about the fact that sometimes platform engineering is sort of misconstrued as, yeah, Kubernetes, right? And it just happened that a couple of weeks back, I was listening to this fantastic podcast from Google. I don't know if any of the listeners have listened to that. It's called Podcast. If you haven't done it, definitely take a listen at that. One of the things that they were talking about is precisely this, right? I mean, they brought in the Kubernetes podcast expert, and they were talking about SRE in the context of Kubernetes and all that. They said, oh, isn't platform engineering Kubernetes? It is not, right? It is one of the 7 different components that actually comprise a typical notion of an engineering platform. So making sure that when you have multiple components in any system, this is not platform engineering, this is not SRE, just simple software design principles, right? When you're building a system with complex components, make sure that it's composable, it's extensible, and replaceable. Because in the previous point, I talked about, hey, use some third-party systems out there. What if you're really getting wedded into that? When you're investing into something like that, if that product goes away, how do I deal with that? Yeah, make it composable and replaceable. So that's a huge aspect to it. The next one, Sean again touched upon it, is the observability side of things, right? It sort of ties in with that first idea of making sure that you measure things. But when you talk about observability, do not confine yourself to the application side observability. This is where another misconception is. Look at observability across the board, across your whole SDLC. Then one of the key principles of platform engineering, we talked about already, is this idea of how do I make the developers more self-sufficient? How do you make the teams more autonomous? I gave you some examples of that earlier, but that is a huge one, the team autonomy. And sometimes the teams don't have the autonomy. If you're still trying to create a modern organization, but I'm going to wait around for some team, whether it is my security team or any other team, to give me something, then that's where the waste happens, right? So you can't have that one. But that last one, the seventh principle in this one to actually achieve that 80-20 rule is making sure that you are defining and articulating value. So this is not the measurement of the friction, right? You have that value articulated. We have built when Sean and I were at ThoughtWorks, our team had actually built certain really good ideas and models, which we'll be talking about in the book, about how do I really measure those values, right? I mean, when I'm building something, who knows, who says that my capability A is better than capability B? Do I just say, just believe me because I've done this for 10 years, so just believe me? No, nobody's going to buy that. Make sure that you clearly articulate that so it becomes easier for us to ensure that we actually achieve that.
Great. I think Ajay and Sean, you have you have covered a lot in this. So you have covered even the next question, which I was going to question. So yeah, so I was uh, drawing from your last answer, I just wanted to understand that you discussed a lot about platform engineering principles. So just a follow-up question on that, what do you think? Do you think there is any confusion or resistance while people start working on platform engineering or understanding platform engineering principles? And are there any gaps, basically, I want to understand? And what has worked for you in bridging those gaps? So if you could explain us a bit about that.
I'm happy to
Yeah, I
start.
think.
Yeah,
Yep.
go ahead, Sean.
Ajay.
All right.
Okay. So
Sean,
guys to figure that out. But what I was going to say here. So I think when, organizations are bringing in platform engineering, again, one reason a lot of organizations do it is because of that desire for standardization and kind of making developers' jobs easier. And one thing that tends to happen is that in making developers' jobs easier and bringing standardization, we take control away from developers. And Jay mentioned developer autonomy. And if we say that, every developer is going to use this deployment pipeline, and now they have to plug into it and everything is going to go to production, and now these teams don't have to worry about building their pipeline, and we know everything's going to deploy in the same way, teams inevitably are going to have some reason that that doesn't work for them. And it will happen every time, whether, it's designed to deploy a single service and now all of a sudden they need to deploy 3 services or something else happens. It's one example where developers will start to get frustrated. Now they're waiting on platform engineering to update what they have and get it back out. Or the team is told, no, you have to make it work with this because that's the way we design things. And now everybody gets confused. Well, did we fix it to make what platform engineering did, or does platform engineering have to fix it for what the teams did? And then nobody ends up wanting to use it, and it just becomes a huge headache for everyone. And really bridging that gap to me is in platform engineering, we talk about making it as an internal product. And the best way to do that is through having a product owner. But with platform engineering, we find that a technical product owner really will help bridge that, because a technical product owner not only understands the idea of putting out a product, finding out what users need, finding out what is required for adoption and tracking features that go out, but they also understand the technical day-to-day of what developers are doing, what sort of features they need, what the platform needs to provide. And they're always kind of interviewing with the developers of where the gaps are in their current day-to-day process, what could make their lives easier, but also more importantly, what sort of flexibility that they need in order to be able to adopt this in a way that is going to abstract some things from them so that now they don't have to worry about it because they don't want to or don't need to, but also give them the ability to maybe go past the guardrails in some cases or override default values or whatever it is that they need in any particular case to make sure that that adoption is seamless, and really kind of organizing that backlog and prioritizing it so that I'm providing the most value and my highest opportunity for adoption so that the organization is now going to realize that.
Ajay, would you like to add something to it?
No, I think Sean covered most of it. So the only thing I would add to that is, so we talked about this role of technical product manager or a technical product owner. And I can't emphasize enough the fact that that is indeed probably the most important role within this whole idea of platform engineering, especially in this context of what we are talking about. But the role of that technical platform manager or the owner is not to just say yes to everything, right? There are multiple things that goes into it. Number one, that person being technical should be able to push back and challenge some of the requirements that developers would want, because every developer is going to come from their perspective. So the role of this person or this role is to look at holistically what is that biggest ROI that can be generated by building a capability like that. Now, the second thing is that the building these capabilities costs some amount of money, time, money, effort. You have to really look at the ROI. If you were to do this as a capability, what is the value that is being unlocked across the whole organization? It's not about that individual. So being able to push back and really challenge and come up with an ideal set of requirements is important. So at some level, we might be thinking we are putting too much on that technical product manager, but it's also the fact that their role is not just to ensure that they actually take everything and build it and provide it, but also to provide that value. We talked about that seventh principle when you talk about the principles, that seventh principle of articulating value. That value articulation sometimes is the difference between a success and the failure of a platform engineering team. One of the oft-repeated questions that Sean and I get pretty much every client we talk to, or even in some webinars and all those things we have done, is like, how do I ensure that platform engineering is sticky. I built this platform engineering team and I got some investment. Now my VPS come to me or my CTOs come to me and say that I need to take this investment away because I don't know what it's doing. Because obviously we know that it isn't creating a visible customer visible value. It is the customer visible value is all about products. So I'm going to take your 10 platform engineers and put them into product development. So when those kinds of things happen, it sort of, we know that sort of impacts the quality of the product and the overall productivity of the engineers. So in order for that to not happen, you also need to have the technical product managers ensure that value articulation and that, the idea of how, what this is unlocking is available across the whole organization.
Uh, Thank you, Sean and Ajay. I think that would be really helpful for the DevOps and technical managers out there who want to start building platform, like want to bring in platform engineering principles and or start building IDPs. So yeah, that was really insightful. So as a follow-up question, Sean, I want to understand that currently you're working on this book, Platform Engineers Handbook. The basic vision of which is build first, clarify as you go mindset, and it is flipping the usual model on its head. So instead of starting with strategy decks and frameworks, we are diving straight into building. So why do you think that approach works better, especially for technologists just starting out in platform engineering? And my second question to that would be, what makes it more effective than leading with theory?
Thanks, Shruti. That's a great question. And yeah, if I think about the type of people that are going to go into platform engineering, as Ajay mentioned, SRE was a look at how do we take operations and put software development practices into operations. And platform engineering is very similar. We want to put software development practices into the SDLC and enabling the SDLC to be more efficient. And then you have this idea that developers like to build things, as Ajay also mentioned. So we'll have software developers that maybe are going to get into this and they know the software development practices from building APIs and doing software architecture. They don't really know how to handle infrastructure. They're not usually thinking about the types of things that an operations team may usually do. Or you have the people that are in more of that operations or even SRE role that are trying to get used to it. And they're used to writing Terraform or infrastructure as code. They're used to configuring enterprise systems, ServiceNow, Dynatrace, things like that. And now they're trying to get into these software development practices where I have a GitHub project and I have release pipelines and I have patterns and practices to harden the SDLC. Platform engineering is a big topic when we say SDLC. So it's not usually easy to just kind of practice that in any way outside of an enterprise organization. It's not usually easy to figure out how do we go everywhere from creating a new project with automation and enabling a team of developers all the way through to running in production, unless we're in that enterprise scenario and we actually have a team of developers. And that leads to us learning what we need to do in pockets, learning what to do as we need to go. And to understand the theory, you have to start with the strategy decks and get people used to this idea of here's what we're going to do, and we'll build it as the backlog goes. By taking more of a build it and then clarify approach, it's going to lead to kind of in the industry, there's the term dog fooding of use what you make. If you start to build something at a very small level that maybe not be applicable to a true enterprise scenario, but is kind of going across the same concerns and patterns, you start to build it from the beginning. And as you build it, you really start to see, oh, it would be easier for me to build this if I implemented this practice. I'm going to deploy a demo application onto what I built and see there's friction in how I'm building this demo application right now. I need these features in the platform. And now you build those features and can see for yourself the difference that it made. And then also see how can I actually measure the difference that made so that now I can truly understand what happened. And because I'm seeing it in action as I go, the theory and the strategy and the process, I think, becomes much more clear because you've actually now seen it in action for yourself in your own project. And hopefully that will lead people that do read the book to now be able to go into that enterprise scenario and see it at the larger scale and understand what they need to do in order to make this work.
Ajay, would you like to add your perspective on this?
No, I think Sean covered pretty much all of the ground here. Yeah. So the idea here, just to reemphasize the fact that what the software developers understand software more than anything else. So show them that, bring them along in that way, then tell them why that is being done. When this first proposal came to us from you guys, Sean and I talked about it, and like it is a challenge for us too, right? Because we are used to telling people, hey, why something should be done and then doing it. Now, flipping that on the head is a phenomenal idea because that, I believe, eventually will bring along a lot more readers and a lot more software developers into the fold, as opposed to them getting bored with the theory and the strategy and all those things up front and saying, I'm not going to read this. I'm not going because this is not very interesting. Now, we believe this will make it super interesting for them to saying, hey, we're first talking about things that they love and they like they would do every day. Now they're saying, why are you doing it? So I think this is a phenomenal way of doing it.
Great. I have a quick follow-up question to Shrishti's question. Jay, you repeatedly emphasized on the 7 principles and the measurement value aspect. Do you think taking this build first, clarify as you go approach will help throw some light on that key aspect of value measurement?
Yeah, another great question. So this was also when we were considering whether we are going to be able to, take up this challenge of writing this book. That was the first question that came to my mind, right? Because we are always talking about measuring something and then improving it. So how does that really work? Now that I think about it more, I feel like this would actually make that whole process far more easier because of the fact that when you are actually building certain things, that when you build it, those values right there, it's not something that we have put in a spreadsheet or some kind of a model or something that is in a theoretical aspect. Developers can see that value right there. Then using the value of what they have built, right? From a cost point of view, definitely. The cost and effort point of view, definitely. Now, what we are really saying is that now that you build that, take that and say that, okay, this is what my effort has actually has unlocked from the point of view of overall productivity. So I think this fits in nicely. It's just that this is going to be one of the unique aspects of this book because I've never really seen a book in which we have taken an approach like that and make it practical. So we have taken up this challenge, and I'm sure collectively we can actually make this a really phenomenal way of looking at things as we move forward.
Great. I really look forward to seeing how the book turns out. Also, Ajay, looking ahead, as more organizations mature their platform teams, how do you see the SRE role evolving? Do you see a dramatical shift in the next few years?
Absolutely, and a great question. So let me actually try and break this down across a few different axes, right? Because there's no simple answer to it. So I'm going to try and simplify it the best I can, and then I'll lean on Sean to actually clarify this further. So number one, the specialization point of view. We talked a lot about the SRE specialization versus the platform engineering specialization. So think of it like SRE is focusing more on that complex reliability challenges, while the platform's handling the complexity of the features that enable the SREs in this case, right? And the developers, of course, right? So as you're really trying to do that, one of the things that have happened a lot more is that partnerships between SRE and the platform engineering teams, because there is still friction in organizations. When we are breaking down the friction for the developers to be able to do this better, there is this brewing friction in some organizations saying the SRE team did the same thing. Why are the platform engineers doing the same thing, right? Which I know is one of the reasons why we are doing this podcast, right? So that partnership will get better because SREs would know that their focus is not to build platforms as a product. They're not building products. They are ensuring that the reliability is improved and increasing and it's sustained. As they do that, they need help to be able to build the capability. So that's where the collaboration will happen. So I think that partnership model will improve. The next thing that'll happen is that higher levels of abstraction. By that, what I mean is that SREs are always working as this at that service mesh cluster level kind of thing, rather than building individual capabilities that will actually go and improve things across the board, right? Because SREs are always thinking about what do I need to do when push comes to shove, when I'm at the forefront of ensuring that my production services are reliable, what do I have to do? Whereas if they are being asked to go build also these capabilities that can help everybody, including their own teams, they are actually not being able to fulfill their requirement because as we know, in most organizations, true SREs are probably the busiest people, right? They are on the forefront all the time. So I think that abstraction layer is going to be different. The other thing that I think we're probably not going to cover this topic in our book, one of the terms I've been using recently, and Sean used to have a role that actually did all of these things in his previous life. What I call is this domain-driven platform engineering, right? This is where we are really talking about ideas of not just from an infrastructure and the actual reliability of the services itself, but as you're building the products themselves, how do I ensure that these platform principles and capabilities are brought in to the products themselves? Now, how does that tie in with the SRE? So I think what I would see that in about 3 to 5 years, again with the advent of AI and all that, you would find that SREs need to be a lot more cognizant and educated on that domain side of things, which was a fundamental principle behind SRE when Google first came out with it. But it has gone in so many different directions that we don't see a lot of that. But I see that happening now. The big elephant in the room, right? AI. So we have to talk about that and how that sort of gets incorporated into this whole context, and we will cover that in the book too. So I would say that SREs have already started using AI for things like anomaly detection, root cause analysis, automated remediation, a lot of those things, right? So these are all the fundamental bread and butter activities of SRE teams. Now, so from a platform engineering point of view, they are the people who are actually going to be providing these capabilities to be able to let the SREs do that job. So I think that is going to be a huge aspect of it. So if I know we don't really want to open that, kind of worms now that we'll start talking about AI, I'm sure all of us can go for hours to be talking about the pros and cons of it. But I just want to lay that out there because that's not going to go away. That becomes actually part of the DNA of everything that we do. So last couple of points on this one. One is the evolution around the risk and compliance side of things. This is something that is probably the most important for a lot of organizations. For example, for pretty much all the financial services organizations that we work with, or in a healthcare organization. I mean, there's so much of compliance and risk aspects of it, and it's true across the board. But irrespective of any kind of regulation or deregulation and things like that happen in the U.S., the fact that these compliance requirements are there. Recently we saw that there's a new AI strategy came from the U.S. government. That is actually trying to deregulate a whole bunch of things. But keep in mind that as you read through that document and all that, there is never any mention of reducing or just taking away the facts around risk and compliance. Those things are always going to be there. So there's more emphasis on that going to come from, SREs, the SREs to be implementing that. But again, platform needs to provide that support for doing that. So that is only going to increase. And as a whole, what you would find is that you'll also find that some of the SRE folks would now figure out that, hey, even though I'm an SRE because my organization didn't have a role of platform engineering, my passion and my interests and my skill sets are more aligned towards building those platform capabilities. So there is this idea of transitioning, some of the SREs transitioning to do more of the platform engineering role, and in some cases the other way around too, but probably less of that. But that is probably what's going to create that diffusion where you see that the ideas and the concepts and the learnings and the experience of the SREs become a natural application to building those capabilities. So that's how I see that evolution happening.
Okay. You've spoken about how SREs can use AI to really bring about change in their work. Sean mentioned that a lot of platform engineering is about automating deployment and other processes like that. So, do you think AI really can make a big difference here in a PE's work? Or do you just think it's a lot of buzz? It's still an early experimental phase. What are your thoughts about this?
Yeah, so I think, Ajay had mentioned with SRE this idea of domain knowledge becoming more important. And, when we look at abstracting things away, it's always been a common argument of I'm going to automate my job away. If you look at database administrators, the cloud came out and had serverless DBs, and DBA said, am I just not going to have a job anymore? Now you're seeing AI come out, and people are saying the same thing. Right? Our software developers a thing of the past because now within a few years we're going to have AI that can write all our software for us. Is platform engineering even needed because we can just have the AI write all the infrastructure's code and do all the analysis of logs that can send out alerts and things? Do we even need this anymore? What I think is really needed here is that SREs, platform engineers, developers need to have more of that domain knowledge so that they can use AI to take away those kind of rote tasks. I need to write the queries to my observability system so that it can alert, or I need to, do some sort of analysis on the logs so that I can preemptively detect problems as they're coming up. Um, if we let the AI start to take care of some of those things and really understand the domain aspects of what does uptime mean? What does good throughput mean? Throughput, if you think of a fintech, throughput for a stock trading application for the day is going to be significantly important to be higher than a batch financial process that runs at 10 o'clock at night after the day is over. That is going to be a lot more tolerant to maybe not running on time or taking longer than it should. And if the SREs start to understand that, and the platform engineers start to understand where they fit into the domain, they can start to now bring the value to the business to say, well, this needs higher uptime, even though it's going to cost thousands, if not millions of dollars more to have that extra 9 on my uptime than the later in the day process. But working with product, we can see that the ROI back to the organization is going to be higher and really help to prioritize those things so that now we can use the AI to actually implement some of these things and put it in place and understand what it's doing. They're going to ultimately be able to bring more value to the organization by being able to do that. So I look at it as a turning point where now you can start to do the more important job to the organization of that analysis, that domain understanding, and really need to do less of that day to day, just writing and debugging code and getting into some sort of iterative loop where it's taking me 8 hours to even get a new feature that works for the day.
Okay. Thanks so much, Sean. Before we wrap, I know we're coming closer to the end of this interview. I'd love to hear from both of you for someone currently in an SRE or DevOps role and now expecting to build or contribute to an internal platform. What's the one mindset shift or practical skill you would suggest that they prioritize? And also, what's the first practical step that they can take to set themselves up for success?
Yeah, so I'll take that first. So for me, the first thing to think about is whenever you are writing a script, whenever you're putting a new feature in place, one of the biggest indicators for success from a platform engineering point of view is once I put this out there and someone uses it, if they need help with it, or they need to do something that that feature is designed to allow them to do, if they have to contact me or put a ticket in to make that happen, I need to improve it because I want to be able to go about my job developing the next feature so that now they can just start using this and be fully self-sufficient with whatever that automation is, whatever that self-correcting behavior on the part of the code is. And if I really start to think about everything I'm producing with that mindset, once I put this out there, no one should have to contact me about it on a day-to-day basis. So I can now move on to the next thing. That's really going to set them up for success as they start to develop this and avoid them getting into that operations role of responding to tickets all day. I'm responding to problems all day.
So Sean actually put it beautifully with some examples. Let me actually just try and tie it all together in the idea of the concept of what this is, right? That the answer to that first question is that developing that product mindset. When you're writing a script, when you're making an automation, doing something, making sure that you're thinking about the long-term viability of it and using all those principles. So that is number one thing. Second thing, this some of the developers might look at this and get surprise, but I would say that build your communication skills, build your soft skills. This is just as important as anything else, and sometimes far more important than your technical skills to be able to do that today. And these were things that developers historically has tried to stay away from. But if you look at the example that Sean gave, having those communication skills will ensure that you are not just selling solutions. In some cases you have to, but you're also understanding and communicating, building the relationships to be able to take the organization to that next level. So do not underestimate that AI or no AI or any advances that we talk about, there is something that is far more important across the board. It has always been so important, is far more important today with the plethora of tools and everything that's out there. Build your communication skills, build your soft skills, build the relationships. There is nothing more important than that.
Great. Thank you so much, Sean and Ajay, for joining us today and sharing your valuable experiences. I'm sure our viewers will really appreciate how grounded your insights were in real world practice, not just theory, which the book is also going to be all about. Viewers, thank you for watching. If you have any thoughts, questions, or topics you'd like us to explore in the future episodes of Deep Engineering, please drop them in the comments. We'd love to hear from you. And if you'd like to dive deeper into the real world patterns that we discussed today, keep an eye out for the Platform Engineers Handbook coming soon from Pact. It's a build first vendor agnostic guide to designing and deploying modern engineering platforms written by practitioners for practitioners. We'll drop the link in the description below once the early access is available. That's all from us, Sushma and Shrishti. This is Deep Engineering. Until next time.
Thank you, Ajay and Sean. Bye-bye, everyone.
Thank you.
Thank you for the time.